Morning. So here's a quick video on how to approach XUS in iXL. So let's take a look. Get rid of some of these things that are clogging up my desktop. So here's what I got open. I have XUS open on iXL. And the other thing you're going to need for all of your transformation iXL assignments are your notes. So pull up transformation notes in C53 worksheet. You can find this in Schoology. It is in your week 8 folder. I would have these up at the same time. I've highlighted translations. I put that in yellow so that you can see what I am looking at. And I'm just going to use this first row as the notes that are going to help me be successful on sliding points and shapes all around the coordinate plane. So make sure you have this open. And I have a pretty good sized computer screen, so I can keep both my notes and iXL open on the same screen. But what I'd actually recommend is that you write these notes down into your notebook so that you can just focus on having iXL up on your computer screen. And then you can just look down at your notes for reference. The other thing is you definitely need to have your notebook anyways, because for all of your translations, you're going to be doing a little bit of math. And in particular, you're going to be doing integer math, adding and subtracting positive and negative numbers. So this is really a good review for adding and subtracting negative numbers as well. So I've got my transformation notes and I'm looking at translations. I've got that highlighted in yellow. I'm here, I am using XUS in iXL, XUS. First thing I'm going to do is I'm going to read and get comfortable with the language of the problems, right? So I've highlighted it here. It says, graph the image of H, -1, -3, after a translation up 10 units. So first thing I'm going to highlight for you in terms of math vocabulary is it says image. So image is a point. It can also be a shape. Okay, so that's what they mean by image. And there's my image right now. It's H. It's a point. After a translation, 10 units up. Okay, these are the key pieces of math vocabulary that are giving me hints about what to do. And we know a translation means you are sliding a figure up or down, left or right. Sliding. Up and down, you're going up or down on the y-axis, up, down, left, and right. And I'm actually going to use a couple of other colors. So I'll use green for up and down, and I'll use red for left and right. But get comfortable with the coordinate plane and these different axes. So this is your X is going left and right. And your Y coordinate is going up and down. Now, if you look at your notes, whenever you're adding to the Y coordinate, you're going up. So remember, your coordinates, these are called ordered pairs. X always goes first, Y is always second. And if you're going up, you're adding. You're always adding to the y coordinate. And if you're going down, so this is up is addition. And if you're going down, you're always subtracting from the y coordinate. And if you are, oops, if you're going to the left, you are subtracting from the x. And if you're going to the right, you're adding to the x. Okay, there's a lot of scribbles up there. Let me just clean this up, and we'll just go through a few examples so this all starts to make a little more sense. Erase, 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 erase. All right, so here we go. Our point is at -1 and -3 on the y. So my coordinates are -1, -3. That's where h is, and I'm going 10 units up. So if I look over here on my notes, I'm going up, I'm adding to the y coordinate, and there's my algebraic notation, which says x, comma, y plus blank, and that is up. Okay, so a couple ways I can do this. So if I'm going to use my algebraic notation and just start doing this addition subtraction, I know that this is my y coordinate, -3. So it's just my y coordinate is going up 10, so it's -3 plus 10, which equals 7. And again, the easiest when you're adding or subtracting positive and negative integers or positive and negative numbers, what I do is I just, when the signs are different, I subtract and I take the number, the sign of the number of the biggest number, okay? So even though this is an addition problem, I just actually just did 10 minus 3, I got 7. I know that the positive 10 is bigger than the -3, so I use the positive sign and I get positive 7. So my new coordinates are -1, comma, 7. -1, comma, 7. That is that's the new coordinates of point H after a translation up. The other way I could do this is just to count. I'm at, again, -1, comma, -3, and I'm going up 10. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 7 on the y-axis. And so I'm at -1, comma, positive 7. That's up 10 units. Key things to notice, my y value changed and my x value stayed the same, right? There was no difference between I'm still at -1. So that's what happens when you go up. Your x value doesn't change, it's just your y value. So I'm gonna put my spot down right here. Bam, submit, got 12 points, I'm happy. Now I've got m equals -9, comma 2, -9, comma 2. That's my point M, it's the image. I'm gonna translate 4 units to the right. I look at my notes, 4 units to the right. I'm adding to the x coordinate. There's my algebraic notation that tells me what I need to do. I'm just going to copy my notation here. It tells me x plus some number, comma y. Y doesn't change. All you're doing is adding to the x when you are going to the right. So I'm at -9, and I'm going to add 4 because I'm going 4 units to the right. and 2 stays there. So I've got -9 plus 4. Again, when I see 2 different signs, a negative and I'm adding a positive, I'm actually just going to subtract and take the sign, take the sign of the bigger number, the number with the bigger absolute value. So -9, I'm just going to go 9 minus 4, that equals 5. And then since the 9 is the bigger value, I know it's -5. So my new coordinates are -5, comma 2. -5, comma 2, which is right here. That's M prime. Now, if I were going to do this, I did this algebraically. I just read the directions and I used the rule. If I were going to just count this off, I'm going to erase all this stuff. You can see that that's what I'm taking this point and I'm going to the right. 4 units, I'm just doing 1, 2, 3, 4, and I end up at the same place. -5, comma 2. So let me put my point right there. Submit. There we go. Happy. Doing well. We're doing well. We are just chugging along. Okay, now graph the image of point P 0,8 after a translation, 6 units to the right and 3 units down. 6 to the right and 3 units down. So I have to do 2 translations now. I'm going to go 6 units to the right. So I'm going to add to the X coordinate. And then I'm going to go 3 units down. And so I'm going to subtract from the Y. So I just circled what I have, the rules. So we're doing right, add to the X, and down, subtract from the Y. And this time I'm just going to count it off first. So I'm going to go to the right 6 units. 1, 2, 3, 4, 5, 6. And then I'm going to go down 3. 1, 2, 3. So my new point should be at 6, comma 5. And let's see if we do this algebraically, if we get the same answer. So I'm 0, comma 8. And my first is to add 6 to, I'm going to go right 6. And then I'm going to go down 3. So that means I'm going to go 0 plus 6 on the X coordinate. And I'm going to go 8 minus 3 on the Y. This gets me 6. 8 minus 3 gets me 5. So whether I'm counting or I am using the algebraic notation in the rules, I get to the same place. I am quite happy. Put that point in there, hit submit. Oh wait, I did not get my point in. Get in there. Let me erase all this. Oh, there, good. All right. So same thing, graph the image, 5, -10 after a translation, 5 units to the right and 5 units up. If you just do this algebraically, you're going to go 5, comma -10, and you're going 5 units up. So it's 5 plus 5, and then -10 plus 5, because you're going up, that's plus, and right is also plus if you look at your rules. Up, add to the Y coordinate, right, add to the X coordinate. 5 plus 5 is 10, -5 plus 5. Again, I'm going to do that little trick that I have for adding negative numbers. So I have a negative and a positive. My numbers are different, so I'm actually going to subtract, even though it says addition. 10 minus 5 is 5, and I'm going to take the sign of the bigger number. So it is -5. Those are my new coordinates, and I'm good. 10, comma, -5. 10, comma, negative 5. 10, comma, negative 5. It's right there. Hello. Now, what I suggest when you get to these problems, so it looks like your SMART score is at 40. Your problems are getting a little bit more complex. So the best way to do this is you got to have your notebook. You got to have your notebook, okay? And the first thing I'm going to do is I'm going to write down the existing current coordinates of T, U, W, V. So it says graph the image of square T, U, W, V. I need to have the coordinates for T, U, W, V down. So let me do this. I'm going to write on the screen. I'm actually going to write on my notebook. But your first step, write down all 4 of the current starting coordinates. So T, U, W, and V, and T, U, W, and V. So T is at point -1, -1. U is at point 1, -1. V is at point 1, 1. And point W is at -1, 1. Okay, so I wrote that all down in my notebook. Make sure you have to be very careful. Make sure you keep everything, your coordinates are matched to each vertices of the triangle. So those are my starting coordinates. And then I'm going to do a set of coordinates after the first transformation, after the translation. So here's how this is what my notebook looks like. Point, I have a column for the starting coordinates, and then I have a column for after translation. And you can see how when you go up on XUS and you have multiple points that you have to translate, how important being able to add and subtract directly from the coordinates are versus counting the blocks. So you want to be able to move to that more efficient strategy. All right, so I've got my coordinates. Now I'm going to translate every single one of them up to the right 1 unit and 9 units down. And I'm just going to put onto this, right, so you can see it on this screen. I'll actually hide my notes, but I'll write onto the screen exactly what you should put on your notebook to be successful here. So here we go. Point. Each corner, either of these points is also known as a vertices. But we've got T, U, W, V, and T is at -1, -1. U is at 1, -1. W is at -1 on the X, +1 on the Y, and V is at +1, +1. And these are this column here, these are my starting coordinates. Now I'm going to do a set of coordinates for each of these after I've done my translation 1 unit to the right and 9 units down. So I'm going to write in here. So in red, I'm going 1 unit to the right and 9 units down. So I'm going to go +1 to the X, and I'm going to go -9 to the Y. That's my rule. That's the algebraic rule that I'm going to apply to each of these coordinates. And I'm going to write the rule right up above so I can just remind myself x plus 1, what I'm going to do to every single coordinate. So that's my rule. And here are my new coordinates. Are going to come up right here. So I'm going to go -1 plus 1, comma, -1 minus 9. I'm going to go 1 plus 1, -1 minus 9. I'm going to go -1 plus 1, 1, positive 1 minus 9, and then 1 plus 1, and then 1 minus 9. And that gets me my final coordinates, -1 plus 1, that's just 0. -9 minus 9, if I am subtracting subtracting negative numbers, I'm actually going to add them and take the negative sign. It's -10. 1 plus 1 is 2. -9 minus 9 is -10. -1 plus 1 is 0. 1 minus 9 is -8. And 1 plus 1 is 2. 1 minus 9 is -8. And there are my 4 new coordinates. And this, all this that you see on the screen right now is absolutely what you should do in your notebook to keep everything straight. So here we go. Let's plot these new points. I'm going to try and keep this up. Well, no, I'm just going to have to erase this. Hopefully you can pause your video here. You can look at this example. I'm going to erase all this so I can actually plot these points. And thank goodness I wrote them all down in my notebook. So now I can actually just go and plot the points. So 1 unit to the right and 9 units down. That was at 0, -8. I'm at 2, -8. There is my thing, and go. All right, so there you have it. I'm going to stop here. This video has been going on for a long time. Hope that helps. That's XUS. We're going to move on to 5UM and HHS